Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Created the first ever video book for you guys where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing. Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends. That is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link. So write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture. And if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video we started with the concept of BJT amplifier. So in amplifier what I told you is we perform small signal analysis, that is we superimpose a small AC signal on a DC signal and we model BJT using the linear element. For linearization we need to have a small signal so that fluctuation in the input signal is very small. So for AC analysis, I told you for AC analysis, what we need to do is we need to ground VCC and we need to short circuit all capacitors. Once this is done, then BJT is replaced by its equivalent model. And then we solve the circuit for mainly 3 parameters. The 3 parameters that I described were input impedance, output impedance, and voltage gain. Other than that, what I told you is I introduced to you one model of BJT, which is Eber's mole model. In NPN transistor, I told you BJT is modeled as 2 diodes. This is your IED. This is ICD. This is alpha F IED, alpha R ICD. Okay, this is IE, IB, and IC. I told you the advantage of this model is it is valid for all operating regions of BJT, but the main disadvantage is it is large signal model and it is non-linear, so it is not generally used. From now on, whatever models we'll talk about, we'll only talk about active mode of operation because we want to implement BJT as an amplifier. So what I told in active mode of operation, ammeter base junction is forward bias. So we show this diode, and collector base junction is reverse bias. So diode is open circuited and ICD is 0. So there is only one current source like this, alpha F IED. This is IED. This is IC. This is IB. Okay. So this I told to you in the previous video, that is in active mode of operation. Ammeter base junction is forward, so we replace it with a diode. Collector base junction is reverse, so the diode is open. So in this lecture, we'll start with T model of a transistor. But remember, from now on, whatever models we'll study, we'll talk about active mode of operation. Just now what I have told you is, in active mode of operation, between ammeter and base, this is base, this is ammeter, P, N. Between ammeter and base, there is a diode. And between collector and base, there is a current source, which is suppose IED. So this current is alpha F IED. This is IC, this is IB, and this is IE. Okay. This is common ammeter, so I have shown ammeter terminal as common. This is what I have showed you here. Instead of just horizontal diagram, I have drawn it vertically, nothing more than that. Now see one thing, this alpha F is basically equal to alpha, and we can say IC is alpha IE. So what I'll do is, I will show this diode and this current will be alpha I. I am using lowercase letter for AC model. This is IB. IB and IC will make IE. Now IC can also be written as beta IB. It is equal to alpha IE as well as beta IB. And remember when we studied about diode, when we studied about AC model of diode, diode is replaced by diode resistance RD. RD was VT over ID. But here the diode current is emitter current. So here this diode is replaced by RE, where RE is VT by IE. This IE is DC current. This RE resistance I introduced to you in the initial lectures when I was talking about common emitter configuration. So I told you that emitter base junction can be modeled as a resistance which is called as the input resistance RE. So how this model will look like? This diode is replaced by a resistance RE. This is the current. I can write it as beta IB or alpha IE. This is collector, base current is IB, and this current is IE. So that is the model of your common emitter configuration. Okay, is it fine? So here, since the diode carries a current IE, the diode resistance is VT by IE. But remember, when we want to find out the resistance for AC model, we make use of DC current. If you are not able to remember this, go back to the diode lecture and see where I have introduced the AC model of a diode. Now we want to make this circuit disjoint. So what is the current in RE or the voltage across base emitter VBE is IE RE. IE is 1 plus beta IB RE, or what you can say IB into 1 plus beta RE. So if we want to modify this model, this is the base terminal. It carries the base current. So between base and emitter, you can show this resistance like 1 plus beta RE. Now if you see, the voltage between base and emitter is IB multiplied by 1 plus beta RE. Initially also this was the voltage 1 plus beta IB RE, but I have taken 1 plus beta with resistance, so the current will now be IB. So I have shown the resistance in such a way that the current in the resistance is IB, but to keep the same voltage drop, the resistance must be multiplied by a factor of 1 plus beta. The collector current source is beta IB, like this, and this is your emitter. So what is the current here? The current here is IB plus beta IB or 1 plus beta IB. Okay, that is the current in this branch. But now what happens is, when we talked about common emitter configuration, when I told to you about common emitter configuration, I also talked about an effect called as early effect. In early effect, I told you that output characteristic is not flat but has a slope, and this is represented by output resistance R out, or you can call it as R naught, which is VA over ICQ. ICQ means Q point collector current. So that is why if you want to show the complete model, what you have to modify is, you also have to show, what you have to show is the output resistance R naught. So this is your beta IB, and here we will show the output resistance R naught. This is your collector, emitter, and emitter is grounded. Always remember this R0 is very high, so in most of the problem we ignore this R0 or we consider it as open circuit because it is in the range of mega ohm. Now if you see, if I want this VCE, this current beta IB will flow in closed loop like this. If it is going from down to up, plus minus will be like this. So this VCE is minus beta IB R0. So it is less than 0. It means this configuration is offering 180 degree phase shift. So this I initially wrote directly that common emitter configuration gives 180 degree phase shift. But even if you see practically, there will be a 180 degree phase shift in the common emitter configuration. Let us see another configuration in T model, which is your common base configuration. Okay. So let me first draw common base transistor. In common base, the base terminal is common. Input is applied between emitter and base, and output is taken between collector and base. Okay. Now as we have seen, the emitter base junction is replaced by a diode. This diode current is IE. Then in collector terminal we show a current which is alpha IE, which means the current in this branch IB is IE 1 minus alpha. This is emitter base collector. Okay. So is it fine? This emitter base junction is replaced by a diode, and the collector base junction we have shown a current source. Now what you can do is you can replace this diode by a resistance. What resistance we showed is RE. Okay. Then this current is alpha IE. This current is IE. So this is the base terminal. The current here is IE 1 minus alpha. And if you want to show the output resistance also, you can show output resistance like this, R0. Now this output resistance is due to the early effect in which the output characteristics are not flat, they have a certain slope. Okay. So that is how you can represent the common base connection. Now in common collector, the last configuration is common collector. In common collector we make use of same model as common emitter. Okay. And remember, when we talk about NPN and PNP, when you talk about NPN and PNP, AC model is same. Now why AC model is same? Because when we talk about AC signal is positive for one half cycle and negative for the other half cycle. That means even if PNP transistor is applied, there will be no change in the AC model. But when we talk about DC current always flows in a unidirection or in one direction. So we have to replace the current direction, or we have to interchange the current direction in PNP and NPN transistor. Like in NPN transistor, emitter current leaves the transistor, whereas in PNP, emitter current enters the transistor. But in AC, current reverses after every half cycle. So entering or leaving current will not affect your answer. The answer will always remain same. That is why the AC model for both NPN and PNP transistors will remain same. And the model for common emitter and common collector configuration is also same. What you have to do, even if you forget this model, replace base emitter junction by a diode and replace collector base junction by a current source, and then you can solve the circuit. So let us see how to apply this concept. So here I have shown you a common emitter amplifier. Emitter terminal is common with voltage divider biasing. Now when you perform DC analysis, the step 1 for amplifier analysis is perform DC analysis. This I have showed you how to perform DC analysis in biasing problems. Okay, for this you must have gone through the biasing problems. After performing DC analysis, we get two things, the Q point IC and VCE. Now step 2, form AC model. Now how do I form AC model? I ground this VCC and I short circuit these capacitors. If we short circuit this CE, RE becomes short circuited. So how you will draw the model? This RE is shorted, C1 is shorted, this voltage is V in. Now see, the top terminal is ground and the bottom terminal is ground, due to which R1 and R2 are in parallel. So I'll show R1 parallel R2. Since ammeter is also grounded, so I have shown this connection here. Now this collector resistance, it is connected between the collector terminal and ground, because now the top terminal is ground. So I will connect RC between collector and ground. RC and collector terminal is connected to V0. So this is your AC model. Now what we have to do is we have to replace this BJT by its T model. How to replace BJT by its T model? So what you will do is, this is V in. This resistance is R1 parallel R2. Now see the circuit of BJT. In BJT I told you this resistance is 1 plus beta RE and the current in this resistance is IB. This terminal is ammeter, this is base, this is ammeter. Ammeter is grounded. Then we connect a current source beta IB. We get this terminal is collector. So I have replaced BJT by a resistance and a current source. Then as I have shown in the model, there is this resistance R0 and RC is connected between collector and ground. This is your RC. This is V0. So what I have done is, I have replaced this much circuit. I have replaced this much circuit in place of BJT. Okay. This is the circuit of BJT. Rest of the components are same. But remember, just the when you are making the connection, you just have to remember the terminal. This is collector, base, ammeter. In base terminal between base and ammeter, I am showing a current source. Sorry, a resistance. Between collector and ammeter, I am showing a current source. That is beta IB. Okay. Now, whenever you have to derive any parameter, let me derive one by one. First, let us go after output impedance. Output impedance is the impedance seen from this terminal, but in output impedance we ignore RL. Since there is no resistance RL here, we don't have to ignore anything. So what is the equivalent resistance here? It can be directly seen, it is R0 parallel RC, because this R0 is also connected to ground. So you can show like this. So these two resistances are in parallel. So output impedance is R0 parallel RC. But most of the times what happens is R0 is very high. I told in mega ohm, but RC is in kilo ohm, so their parallel combination is almost equal to RC. Then we talk about input impedance. Input impedance, I told you ignore RS. We haven't shown any RS. So if you see from the input side, this is Zn. This resistance is also grounded due to this terminal. So these two resistances are in parallel. Input impedance is R1 parallel R2 parallel 1 plus beta Re. Sometimes if beta is high, 1 plus beta is replaced by beta. So it becomes beta Re. Okay. Now when we have to talk about voltage gain. So see this. I will replace this entire resistance by a single resistance. What single resistance I will replace it? I will replace it by a single resistance, that is Z out. So what about V naught? This current will go like this, plus minus, but V naught is like this. So V naught is negative beta IB into Z out. Now we want to find the relation between V naught and V in. When we talk about voltage gain, we want to find the ratio of V naught and V in. If you want to find the ratio of V naught and V in, you have to find this IB. This IB is the current in the resistance 1 plus beta Re. So how you can write IB? Since these two resistances are in parallel, the voltage across each resistance is V in. So IB is V in over 1 plus beta Re, or you can say V in over beta Re, which means V naught is, if you replace IB by its value, minus beta V in by beta Re into Z out. So this gets cancelled. So the voltage gain V naught by V in is minus Z out over Re, which means that the voltage gain is minus R naught parallel RC by Re. As I told, R naught parallel RC is approximately RC. So minus RC by Re. The negative sign indicates that there will be 180-degree phase shift between the input and output. So remember, the output signal will be inverted version of input and it will be amplified by a factor of RC by Re. Okay. So that is how, if you replace BJT by its equivalent circuit, you can find any parameter that you want to find. Moving on, now suppose if I remove the capacitor that was here, C3. I have removed this capacitor. When you remove this capacitor and you draw the AC model, then this capacitor will be short, this will be short, this VCC will be ground. Then how you will deal with it? As I have told previously, R1 and R2 will be in parallel. So V in will be connected at the base terminal. At the emitter terminal, we will have a resistance Re. Okay, now this Re will not be grounded because C3 is not present. At the base, we have a parallel combination of two resistances R1 and R2. And this collector resistance, it is connected between collector and ground. So between collector and ground, we will place a collector resistance RC. And this collector terminal is connected to the output voltage V0. Now what we do in the next step? In the next step, we replace BJT by its equivalent circuit. So let me draw the equivalent circuit. So how you will draw it? I'll not show this ground. Sorry, not show this terminal. I'll connect this to ground. R1 parallel R2. This is V in. Now we have reached the base terminal. Between base and emitter, we will show a resistance which is approximately beta Re. Now I am saying beta is much greater than 1. So 1 plus beta is approximately beta. the emitter terminal is connected to RE and RE is connected to ground. Between collector and emitter we show our current source beta IB. Then we show a resistance R0, and then between collector and ground we show a resistance RC, that is V0. Okay. Now see this thing, emitter terminal is not directly grounded. Emitter terminal is grounded by means of RE. The current here is IB. So now here what assumptions I have taken? I have taken an assumption beta is high. So 1 plus beta is approximately beta. We make another assumption that R0 is high in order to simplify the circuit. So we will treat it as open circuit. So what I will do is, I will treat it as open circuit. Now if you want to find out the output impedance from here, Z out. In this circuit you can write down Z out is simply one resistance RC. That is your output impedance. Now when we talk about input impedance, the input impedance is V in over I in. I in is I1 plus IB. So I will say Z input is V input by I input, where we can write I input is I1 plus IB. I1 is V in over R1 parallel R2. And what about IB? IB we have to calculate. How will I calculate IB? If you see, the current here is 1 plus beta IB. So if you apply KVL in this loop, what I'll say, the total voltage is V in. V in is, if you see, IB into beta RE. So IB into beta RE, or actual resistance is 1 plus beta RE, plus the current in this resistance is 1 plus beta IB. So 1 plus beta IB into RE. So it is IB 1 plus beta RE plus RE, and if beta is very large, beta IB RE plus RE. Okay, that is the input voltage. So how you can calculate IB? IB you can write as V in over beta RE plus RE. Once I know I in, I can calculate Z in. V in upon I in, that is 1 over 1 by R1 parallel R2 plus 1 by beta RE plus capital RE. So this is actually R1 parallel R2 parallel beta RE plus capital RE. Now this capital RE is actually much greater than small re. So sometimes we also write it like this. If capital RE is much greater, beta capital RE. But this is only valid when capital RE is much greater. Now the last step is calculating the voltage gain. So I am removing these things. If you want to calculate voltage gain, see, this beta IB current comes like this. So it is coming like this, beta IB. So the voltage is plus minus like this, but V0 is opposite polarity. So what you can say, V0 is minus beta IB into RC. Now we know IB can be written as V in from this equation by beta RE plus capital RE, which means beta gets cancelled. minus RC over RE plus capital RE into V in, which means V naught by V in, which is the voltage gain, is minus RC over small re plus capital RE. Now see in the previous case. In the previous case, what was the gain? The gain was minus RC by small re. In this case, what is the voltage gain? Minus RC by small re plus capital RE. That means due to this capital RE, the voltage gain is reducing, and that I told you initially also that if you don't bypass this resistance RE, it acts as negative feedback and it reduces the gain of the amplifier. And that is the same thing that is happening here. Due to this capital RE, the gain has reduced. Okay. So what is the significance of capital RE? It stabilizes the Q point. What is the disadvantage? It reduces the gain. And that is why we use a bypass capacitor, so that capital RE does not appear in the AC analysis. Okay. Moving to another circuit. But also remember one thing, when I am teaching you all those things, you don't have to memorize these formula. Just observe how I am tackling this concept. Okay. Now the next circuit is ammeter follower. Ammeter follower is basically also called as common collector configuration. And why it is called as ammeter follower? Because output voltage is taken from ammeter. So you can say the output voltage follows the ammeter voltage, and hence we are calling it as ammeter follower. Now see how we can design the circuit. We will first short circuit the VCC. We will short circuit the capacitors. How will the circuit look like? See, this V in is connected to the base of transistor. So this terminal is base. This RB is connected between base and ground. So I will show RB here. Okay. This RC is connected between collector and ground. So I will show RC like this. This RE is connected between ammeter and ground. This is RE. Now we have to show the model of BJT between base, collector and ammeter. So what I will do, between base and ammeter I will show a resistance beta RE, assuming beta is much greater than 1. Between collector and ammeter I will show a resistance, a current source, which is beta IB. This current is IB. And again I am assuming R0 is open circuit. This assumption I am taking in order to simplify the analysis. Okay. So that way you can skip one step. When I was showing BJT, what I have now done is I have directly replaced BJT by its equivalent circuit. Now again I have to find the parameters of this circuit. So the first parameter is the input impedance. So input impedance is V in by I in. Now in this circuit, if you want to calculate I in, it is simply I1 plus IB. Now this I1 is V in over RB. But how to calculate this IB? See the current in this resistance. It is 1 plus beta IB. IB is coming here, beta IB is coming here by KCL, 1 plus beta IB. So if you want to find out IB, you will apply KVL like this. So you will say that V in is equal to IB into the actual resistance is 1 plus beta RE. We approximate it as beta RE plus 1 plus beta IB into capital RE. So this is 1 plus beta IB small re plus capital RE. Now if 1 plus beta is equal to beta, or beta is very high, So that way you can write down IB is V in over beta RE plus capital RE. In this case now, say this is I in. In this case now, if you calculate Z in, which is V in over I in, it will be 1 over 1 by RB plus 1 by beta small re plus capital RE. Or what you can say, it is RB parallel beta RE plus capital RE. Okay. So that is your input impedance Zin. Now, if you want to find out output impedance, okay, if you want to find out output impedance Z out, how do we calculate Z out? It is V out over I out when the input voltage is 0. So in this case, what you have to do is, you have to ground this. If you ground this, this RB becomes grounded, and we have to calculate V0 by I0. Now, how will you calculate this terminal or this term V0 by I0? So, now, one thing, that this current will not be simply 1 plus beta IB, it will be 1 plus beta IB plus I0. So, in this circuit, what you can say? V0 is 1 plus beta IB plus I0 into RE. Okay. Now, we want V0 by I0. So, I want to remove this IB. For that, what I'll do is, I'll apply a KVL like this. Okay. So, if I apply a KVL like this, I'll say 0. This is 0 voltage. The voltage here is IB into beta RE minus IB into beta RE, or exactly 1 plus beta RE. Then this is equal to the voltage V0. So IB is minus V0 over 1 plus beta RE. So that way what I can say is 1 plus beta IB is equal to minus V0 by RE plus I0 RE. Now when you take V0 terms on one side, so what is V0 by I0? RE over 1 plus capital RE by small re, which is equal to RE over RE plus small re, or you can say RE parallel small re. So that will be your output impedance Z out. Okay. So in this case, don't directly say that Z out will be RE. You have to calculate V0 by I0. Otherwise, I'll show you one shortcut. Okay. When we started with T model, what I said is, if you show the resistance RE in the emitter terminal, if you show the resistance RE in the emitter terminal, I was showing it as small re. Let me show you. If you want to understand this, see. Initially, when IE current was flowing, I was showing the resistance as RE. When I transferred it to base, when IB current was flowing, I made this resistance 1 plus beta RE. So what you can say is, when you transfer the resistance from emitter to base, when you transfer the resistance from emitter to base, multiply by 1 plus beta. Similarly, when you transfer the resistance from base to emitter, you have to do opposite, divide by 1 plus beta. So see this thing. Now I'll show you how to calculate directly. See in this circuit, I want to refer this resistance at the emitter terminal. If I want to refer it from emitter to base, I'll divide it by 1 plus beta. And since beta is high, I can say I will divide it by beta. If you divide it by beta, what it will become? Re. So if it becomes small re, then what I will do is, if I refer it to the emitter circuit and it becomes small re, then what you will do is you will show like this. Now the total input impedance is capital Re parallel small re. So remember, when you wish to refer a resistance from emitter to base, multiply by 1 plus beta or simply beta. And when you want to refer it from base to emitter, then divide it by beta. Now let us find out the output voltage upon input voltage, that is the gain of the amplifier. So now I am removing this I naught. Okay, this short circuiting also I am removing. So this resistance is beta Re. This is your V naught. So now the current in the ammeter resistance is simply 1 plus beta IB. Or let me solve it there itself. So I'll remove this. Okay. Now if you want to find out the voltage gain, so V naught is 1 plus beta IB into Re. But I want to find out IB in terms of V in. So again I'll apply KVL like this. So I'll say V in is IB into actually 1 plus beta Re, or beta Re you can say, plus V naught. So that means IB is V in minus V naught by 1 plus beta Re. If you substitute this value here, so 1 plus beta into IB will become V in minus V naught by small re into capital Re. That means Re V naught equal to capital Re V in minus capital Re V naught. From here if you calculate V naught by V in, it will come out to be capital Re over small re plus capital Re. So this is positive, means 0 degree phase shift. So that is what I told you, in common collector configuration there is 0 degree phase shift and this gain is less than 1. So common collector configuration gives a low value of voltage gain. The gain is less than 1 and it provides 0 degree phase shift. Lastly, let us see what happens if we consider the source and the load resistance. Up to now I haven't considered RS or RL. So in this I am considering voltage divider bias with C3, that is the ammeter bypass. So I am showing the circuit simply. This is your supply. We will show the source resistance as well, RS. In voltage divider bias, we have a resistance R1 parallel R2. Then we have a resistance beta Re. It carries a current IB. Since ammeter has a short circuit capacitor, so ammeter is grounded. Then we have a current source beta IB. Then we have a output resistance R0, which is actually very high. Then we have a resistance RC connected between collector and ground. And now we also have one more resistance RL. This is your V0. Okay. Now the input and the output impedances are not affected, because while computing input impedance we ignore RS and while computing output impedance we ignore RL. So what is the effect of the source and load resistance? They affect your voltage gain. Now see this, all these three resistances in parallel can be replaced by a single resistance. If you replace it by a single resistance, what you will write? we will write R0 parallel RC parallel RL. Now this current will go like this. So plus minus will be opposite to the polarity of V0. So I will say V0 is minus beta IB R0 parallel RC parallel RL. That will be the value of V0. And if R0 is very high, so you can ignore R0 and you can write down like this, RC parallel RL. Now we want to find out this IB. This voltage is called as Vin. So Vin is basically IB into beta RE, or you can say IB is Vin over beta RE, which means that you can write down V0 is minus beta by beta RE Vin into RC parallel RL, or you can say V0 by Vin is minus RC parallel RL over RE. This is called as AVL. L represents that we have assumed the load resistance RL, we have not ignored the load resistance RL. Earlier we derived, in the first case we derived the voltage gain as minus RC by RE. But now in the numerator we have RC parallel RL. So what you can say, AVL is less than AV. AV is the open circuit voltage gain where there was no load resistance RL. This gain that we derived earlier was AV. But this is V0 by Vin. This is not V0 by Vs. If you want to find out V0 by Vs, how you will do it? We have to find out Vin in terms of Vs. So if you see, these two resistances are in parallel. So what you can say, R equivalent is R1 parallel R2 parallel beta RE. Once you have this R equivalent, you can find out Vin by voltage division between RS and the parallel combination of the two resistances. So that is Vs into R equivalent by R equivalent plus RS. So that means if you have V0 by Vs, if you want to find out V0 by Vs, you will write V0 by Vin into Vin by Vs. V0 by Vin is how much? That we are writing as AVL. Okay. So V0 by Vs is called as AVS, that is considering the source resistance. So V0 by Vin, as we have shown here, it is AVL into Vin by Vs. It is R equivalent by R equivalent plus RS. Now this factor inside the bracket is less than 1. So this value is less than AVL. So what you can say? AV is greater than AVL is greater than AVS. Which means if you consider load resistance, the gain reduces, and if you consider source resistance, the gain further reduces. So due to load and the source resistance, due to the voltage drop across them, the gain of the amplifier always reduces. So if any question, it is just asking you the voltage gain, you find out V0 by Vs. Don't get into this terminology AV, AVL and AVS. Find out the final gain, which is V0 by Vs. Always in problem, the voltage gain should be overall voltage gain considering RS and RL. So let us summarize what we have learnt here. We first studied about T model of BJT. In T model, I showed you that we show a resistance beta RE like this, and then we show a current source beta IB, and this is the output resistance R0, collector, ammeter and base. Okay, this current is IB. Then we saw voltage divider bias. In that we derived the voltage gain was minus RC by RE. This small RE is nothing but thermal voltage by ammeter current. Then we saw in case of unbypassed RE, in which we did not bypass capital RE, the gain was reduced, it became small re plus capital RE. And then we saw ammeter follower configuration. In ammeter follower, we saw that the voltage gain became minus RE by RE plus capital RE, which is less than 1. Sorry, it was plus, which means 0 degree phase shift. The other two voltage gain were negative, which means 180 degree phase shift. And I told you, due to RS and RL, the voltage gain reduces. Hence, AV is greater than AVL is greater than AVS. So, voltage gain keeps on reducing if we consider the load and the source resistance. Okay. So, in this entire topic, you just have to understand how to draw the BJT model. So, in next video, I'll tell you how to solve problem by constructing network and without memorizing any direct formula. That we'll see in the next video. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very, very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very, very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. and share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.